Okay, so welcome back, and now what we're going to do is we're going to start talking about arc length, we're going to talk about radians, and we're going to focus on converting between degrees and radians. Okay, so to start with, let's introduce the circle, right? So we have a circle with a radius r, and we know that the circumference of the circle has this formula, okay, 2 pi times the radius. Okay, now, what is an arc? Okay, so an arc is what's created by the intersection of two radii to the edge of a circle. So the arc is the curved distance that is intersected by a central angle. So two radii with the central angle intersects on the edge of the circle, and that creates what we call an arc. Okay, and the arc length is the length of the curve based on that angle, based on the central angle. Okay? Now, to talk about radians, let's first talk about this formula for circumference. So we know circumference is equal to 2 pi r. Okay? Now, if we divide both sides by r, we get this ratio. And the ratio says that if we take the circumference, the ratio of the circumference to the radius, we get 2 pi, which is a constant. Okay? So now, what is this saying? Well, very simply, it's saying that if I take the circumference and divide by r, I'm saying how many radiuses, right? How many lengths of the radius do I get out of dividing by the circumference? So in other words, I'm taking the circumference of the circle, which is the distance around, right? And I'm dividing up that circumference into equal lengths of size r by the radius. So if I do that, I get 2 pi, which is approximately equal to 6.28. So basically what this is saying is if I subdivide the circumference into equal sections of r, right, of length r, or arc length of r, then what happens is I get 6 equal wedges and then a sliver, a little left over at the end, which is that 0.28. Okay, so that means what? This is 2 pi is what we can get from dividing the entire circle, the circumference of the circle. So what does that mean? Well, that means that this is also equal to 360 degrees. Now, also keep in mind what this also says is that this ratio, and by the way, it's a length divided by the length, right? So it's a length divided by length, so the dimensions cancel out. So this is a unitless number, and so this is how we define a radian, right? So this is what we call the radian measure. So how do we define a radian? Okay, so based on this is 2 pi radians. So what is a radian? It's the arc length. So let me draw. So it's arc length such that the length of this arc length, or the measure of this arc length, is equal to the radius. And so the measurement of the angle, the central angle, this central angle is equal to 1 radian. So that's how we're doing. So basically, how many of these? We can fit 6 of these wedges and then a little bit. So each one of these wedges has a central angle equal to 1 radian. So let me repeat. So when you have a central angle such that the intersection of the rays, right, that intersect the circle, such that the arc length between those two rays, or between those two radii, is equal to the length of the radii, then the central angle by definition is 1 radian. Okay, and how many radians are there? Well, 2 pi radians, or approximately 6.28 radians. Okay, now, so that means that, guess what? This ratio is constant, regardless of the length of the radius. Okay, so 2 pi radians, right? So this is 2 pi radians is equal to 360 degrees. So one circumference, right? So one circumference around is equal to 2 pi radians, which is also equal to 360 degrees, right? Which also we can state that if we divide both sides by 2, right, pi radians is equal to 180 degrees. Okay, so far so good. Now, so what is the measurement of 1 radian? What if I want to measure this in degrees? Well, how do we do this? Well, this is 2 pi radians, right? So 2 pi radians equals 360 degrees. Then what if I divide both sides by 2 pi, right? Because I know that if 2 pi radians is 360 degrees, pi radians is equal to 180 degrees, like I said. Well, what's 1 radian? Well, 1 radian is equal to 180 degrees divided by what? Pi, which is approximately equal to 57.3 degrees. Okay. Now, let's talk about arc length. Okay. So in general, if we have theta, right, and this is the arc length, and arc length is denoted by S. So how does arc length relate to radians? Okay, well, just like the circumference is constant in terms of radians, right, with respect to a ratio, so this ratio is the radian measure, with respect to the circumference, there's also a similar relationship with regard to the arc length. Okay, so again, just as the full circumference of a circle always has a constant ratio with the radius, the arc length produced by any given angle also has a constant relation to the radius, regardless of the length of the radius. Okay, so now, since the arc length is only dependent on theta, okay, so how do we find S? S depends on the central angle theta. And it turns out that S is equal to theta times R. Now, again, how we measure theta, right, Because again, if we know the radius and we know the angle, then the arc length is going to be that angle times the radius. Okay. Now you can derive this by using the circumference, right? You could use this circumference formula and say, well, the arc length is going to be what? A fraction of the circumference. Now the arc length could be a fraction of the circumference. It could be the entire circumference, or it could be more than the circumference. Obviously, if theta is larger than 360 or 2 pi radians, right? But the point is that I can write this as a fraction, that the arc length is a fraction of the circumference. Okay, so I can derive this directly from this. But here's the point. I can show that the radian measure of the central angle is also a ratio of, like I said, this arc length with the radius. So I can measure theta as the ratio of the arc length and the radius. And again, this is constant, regardless of the radius length. Okay, so you might be asking yourself, okay, now what? Okay, well, now this property, the fact that it only depends on the angle, allows us to define a measure of any angle as a ratio of the arc length, S, to the radius R, which I have on the board. Okay, so again, if S is equal to R, well, what does that give me? So if S is equal to R, again, this is radians, right? So that means if S is equal to R, right, I get R over R, which is equal to 1 radian. Okay? Which goes back to what I was saying earlier about how we define 1 radian. Okay, again, this is the radian measure. Okay. So now let's do an example. And let's consider 2 circles. Okay? One with a radius of 2 and the other one with a radius of 3. Okay? So in this case here, we got a circumference that's equal to 4 pi. And here we've got a circumference that is equal to 6 pi. Okay? And now what we're going to do is we're going to consider a 45-degree angle. Okay? Now, if we consider a 45-degree angle for both circles, think about what that means as far as the fraction of the circle. Okay, so from when we were talking about before about the angles, right? So 45 degrees splits one of the quadrants in half, right? Okay. Now, okay. So if we take the arc length, right? The arc length for this one. And we divide it by the radius, right? What do we get here? Well, here we get ½ pi for the smaller circle. Okay, why? Because a 45-degree angle contains 1/8 of the circumference of a circle, right? So if it's 1/8 of the circumference of a circle, and we know that the circumference of a circle is equal to 2 pi radians, right? So 2 pi divided by 8 right? Gives us 1/4, right? But in this case here, the circumference is 4 pi. Or excuse me, so it's 2 pi r, right? So in this case it's 4 pi, so again it'd be 4 divided by 8, that's where the 1/2 pi comes in. Here it's 6 pi. So then the circumference here is going to be 6 pi divided by 8, which gives us what? It's going to be what? Three-fourths pi. Now notice what happens here. What do we get for this? This gives us 1/4 pi. And if we do this one, watch what happens. This also gives us 1/4 pi, or what we normally say, pi over 4. And so pi over 4 radians is the same as 45 degrees. I'll see you next time.